Okay, let's see. Last session of NDC. I want to talk to you about IoT, and specifically Norwegian Technology and how that actually makes IoT simple. My name is Joakim Lindh. I am IoT tech lead at a company called Webstep. Previously, I worked for a company called Texas Instruments, where I was an embedded C software developer, so that's my background. I worked with embedded connectivity solutions, sort of within Internet of Things. Now I moved on to kind of the higher level of the software realm, where most of the people at this conference actually work within, to try to combine what is, the hardware, the kind of nodes, the IoT stuff that's out there, combine that with the cloud solutions that become more and more popular. So I'm going to go through this talk, give you a couple of examples, talk a little bit about my experience, what I've seen when working with customers all around the world, kind of the tips and tricks, so try to feed you with some portion of thoughts in the hopes of inspiring you and also make you understand why software is the key for the Internet of Things and why software developers are really, really important for the future. So let's start with a definition. What is Internet of Things? Depending on who you ask, you're going to get different types of answers. You're going to get different depth of the answer. I like to keep things simple as possible. For me, Internet of Things is the digitalization of the physical world. And by that, I mean that you take something in the real world and you represent it in a digital form. Simple as that. So if we take a simplified architecture of Internet of Things, I like to talk about a node that could be, for example, a sensor that measures humidity, temperature, pressure, whatever in the real world. That information is sent up to some sort of gateway. Now, depending on how you send the data, there's different types of gateways. You have like a telecom base station. If you, for example, think about Sigfox, NB-IoT, LoRa, you have those kind of solutions. Or it's your smartphone that connects to this sensor. Then we talk about Wi-Fi, Bluetooth low energy. Or it could be proprietary solution. Now, proprietary solution is more often used when you want to get full robustness and absolute minimal power consumption. I'm going to show an example on just that. Then comes the interesting part, which is why I actually moved in from the hardware world into the software realm, because at the cloud, that's where the interesting stuff happens. This is the place where the data comes in. This is the place where you can store the data. You can do analysis on the data. You can do predictions into the future. And you can actually control based on the decisions made in the cloud. Today, we don't control that much from the cloud. Today, we simply represent data in a visualized way for people that then can do things manually. In the future, we will be able to loop back this information out to not sensors, but something called actuators. And then you have the full loop from the physical world into a smart system and back out to the real world again. And why is so many companies interested in this IoT? I mean, the concept IoT, if you really look at the definition of it, it's been going on since the 60s. But why are people so interested in this now? Partly it's because of Moore's Law, but I'm going to talk a bit about that later. But let's just look at some numbers. So Gartner, they stated that in 2020, 30 billion devices are going to be connected. Forbes, Cisco, Ericsson, they also give their own statements about this. Cisco actually states 50 billion devices. That's 6 more than actual people on the Earth, 6 times more. So in general, we're 7.5 billion people. Today, we're 7.7 around 2020. So that's a lot of devices that's going to be connected. And if you look at the actual market for this, if you Google IoT, you're going to get a lot of answers on smart homes. And that's the most common example because it's easy to relate to. As a person, it's the most easiest way to relate to Internet of Things by thinking about security at home, home automation, things like that. But when I look at Internet of Things, I see some other parts which are more interesting. This chart shows some other interesting areas. For example, in manufacturing, we talk about optimizing a process to make it either low cost or to simplify it. And if you think about it, if you automate a process and make things really low cost to produce, and if it's not dependent on actual labor costs anymore, you can bring back a lot of manufacturing that is now done in, for example, China or whatever in the world. You can bring that back into Norway, Sweden, or whatever you want to do the manufacturing because it's not about labor costs anymore. If you think about healthcare and wellness, think about elderly home. Think about the person who works there. Think about all the administrative stuff they need to do, hand out pills, keep track of things. What if, with IoT, we can make those things automated, and the people who work there could instead be out with the old people, holding them in their hands and listening to their stories. So it's not about just removing jobs, which a lot of people are actually afraid of. It's about also redefining the type of jobs that people will do. So there's a lot of interesting things going on when we look at the market, not only smart homes and drones and cool stuff. This is probably the last business slide I show you, but I just want to make you understand the value of Internet of Things and how you create the value. So you talk about something called value chain. That means you take something raw and you run that through a pipe, and that turns into business value. So in IoT sense, you would go from sensing something, for example, with hardware, going up to the cloud, doing some sort of storing, analyzing, making decisions, controlling, which is more software related. So you go from hardware to software to monetization. From a business model standpoint, the story is a bit different because this is how the business models would look like as well. But for IoT, it's a different concept because it becomes more complex and multidimensional. So instead of value chain, we talk about something called value network instead, where companies, co-produce the actual value. That's kind of interesting. It also creates something called museum of partners. You're going to see that if you go to the website, you're going to see partners. You're going to see like a big list of partners. And I don't think they actually maintain the connections with all of those partners. So that's kind of an interesting part of it. But let's get a little bit more technical. I want to talk about the technical challenges. So I was, as I said, working worldwide before in a large corporation. I work with customers, and I often stumbled across one of the main challenges when they designed the IoT products, the IoT solutions. From the node perspective, typically you have a small ARM processor that runs on a small coin cell battery. So when you write the code, when you write the solution for the node itself, you're very limited to the actual code you can write. These things typically runs on 128 kilobytes of flash with like 8 kilobytes of RAM. So everything needs to be very optimized. But you can't optimize it too much because you need to be able to do software upgrades. You need to be able to do monitoring, run diagnostics, things like that. So that's the big challenge from the node perspective. Adding to that, you have obviously the connectivity, which I'm going to touch in a little bit more detail later. But you have the challenge of choosing the right technology. As we will see, most of these solutions that enable connectivity today, they actually are software programmable. So even though the radio front end itself is hardware, you can, by software, change between, for example, Bluetooth, Zigbee, Wi-Fi. That becomes more and more enabled out there in the world. Even though interoperability is still a big challenge. If you have a Bluetooth product, it doesn't matter, it actually can connect to your phone. So there's a lot of problems with interoperability, and obviously security. Security is the main topic, and you probably heard us multiple times during this conference about the attack last October with the Mirai botnet, where somebody actually, through a IRC channel orchestrated an attack against Dyn, who is a DNS provider. And they actually used IoT or IoT devices to do this. VCRs, things like that. Somebody stated connected vibrators, and people actually blame a lot of different kind of IoT devices. But in the end, it's just devices that haven't changed the default password on. But there's a lot of problems with security. And one funny thing is, there's a catchphrase for when you talk about IoT. You often say that the S in IoT stands for security. Have you heard that before? Yeah. And it's kind of true. It is true. In the network sense, so you have the node. Maybe you've been able to complete all these steps. From the network perspective, you have complexity. And the complexity, I mean by that is you need to maintain a lot of different nodes. Typically, these networks maintain different type of protocols, and this need to be robust. This is like the bottleneck in the system. So there's a lot of challenges here. Connectivity, interoperability, and security are actually the top-rated technical challenges. In the cloud, however, things are a bit different, because in the cloud you have infinite processing, infinite storage, sort of. So the problem there becomes another discussion. There instead we talk about the amount of things going in and what speed they have into the cloud. So this is actually, I'm starting on the definition of big data here, which applies to the cloud. So you talk about the speed, the volume, how much data comes in. The variety is what kind of different data comes in to your system. And finally, can you actually trust this data that goes into the system? And you need to be able to do live processing. You need to be able to handle historical data. And also, typically, you run predictions, which is why cloud is actually ramping up significantly now if you look at the different providers. Now, why are people actually going from on-premise solutions? They have their own server rooms, but they go over to cloud. Why is that? It's because it's a lot cheaper, and it allows you to ramp up. The time to market is really small. It's scalable. I mean, when your network needs to grow, you do it by software. And it's secure. Many people, they actually say that they don't dare to go to cloud because of the GDPR and the things going on, but that is the reason why you should go to the cloud, why you should deploy your code at the cloud. So as a service is becoming more and more interesting, where you put a lot more of your things on the cloud solution instead. And you have redundancy and so forth. So let's take a look at the big players. There used to be 4 big players that we talk about, so Amazon, Microsoft, Google, IBM. When it comes to the cloud offering and people going to these solutions, IBM has been ramping down a bit, and I think that's because they've put a lot of focus on their cognitive computing with the Watson, Pepper, and all those things, while Amazon, Microsoft, and Google has put in a lot of effort, and I dare to say that actually Microsoft is dependent on Azure going gold. Otherwise, they're going to have big problems as a company. And if you look at from an IoT perspective, this is interesting. If you look at what these 3 guys are providing, Google, Microsoft, Amazon, they're providing on a paper, they're providing the exact same things. All of them have storage. They have some sort of IoT hub. It's called IoT hub in Microsoft. It's called IoT core in Google. It's called just IoT in Amazon. It's just a bidirectional kind of hub that allows you to do provisioning and security as well. They all provide some sort of edge. Have you heard about the expression fog? Any of you? No. Okay. Some of you. Fog is cloud. It's a part of the cloud that actually executes out in the network or in the node. That means that if you have downtime, you can do some of the processing that you usually do in the cloud, you can do that out in the edge. So therefore, they call it fog. But it's kind of interesting how these guys actually release. How many of you do get newsletters from Amazon about their new services? Yeah, 1, 2, 3. It's quite interesting because you can wake up in the morning and you open the email and it's like, bam, this much new services. And 2 days later, bam, it's new services. I attended a training yesterday that Amazon actually arranged. And the guy who was there was the technical evangelist. Even he couldn't keep track of all the services and new stuff that they actually add to their cloud solution. So imagine the people who needs to choose between these and try to figure out which actually services to use. For IoT, it's quite simple though. Anyhow, let's move on from cloud and take a look at the evolution of Internet of Things. I'm going to give you a concrete example shortly, but I just want to first refer to this. Michael E. Porter created this, a really nice article about Internet of Things, and you see the title down here about the future of IoT and how products change. And so if I talk about a coffee machine, that's a product. And you add a display on it, and you have a smart product. Your coffee machine can tell you it's time to fill up the beans. Or you can see a display when it's time to clean the machine, so forth. You add connectivity to it, and all of a sudden, you can get a notification when it's time to buy new beans. Or you can, for example, have it order it by itself. You can also, for example, enable it so that when your alarm rings in the morning, it actually makes you a coffee, so it's ready for you. Moving on, we have something called product system, which means that you start connecting things to your coffee machine. That could be, I don't know, a milk warmer or something like that. Then in the future, we look at like 2020, 2025, and this is not numbers from the article. This is numbers or me and my colleagues made up. And it's what we think is the actual time frame, because these product systems are going to be able to talk to each other in the future. Some systems already do this today, but you're going to have this, as I talked about, the system where you have sensors and actuators. And to illustrate this, we have a real product that follows this process quite similar. Do you guys know what radon is? How many of you know what radon is? Most of you. Radon is a deadly gas that kills you, which is not good. So you can actually, and it's available everywhere, and you can measure the radon by, I don't know which year this is from, but you place this in your home, and you had it lay there for a while. You send it off to an institution, you get results back by a letter that says, hey, the radon is high, you should do something. Today, AirThings, a Norwegian company, they created a way to monitor and present this information directly to the user. So you have a smart product. This year they released Air Visualizer, which essentially measures the radon, and it can push the information to your smartphone so that you can know if it's time to do something about it. Now, if you imagine this going into a building with multiple apartments, or a bigger area, or a city, you can get sort of a state of the radon over time. So you get a more advanced system where you can collect and do interesting things. It doesn't get that interesting here, though, but what gets interesting is when you combine this data with other types of data. So you have the system of systems architecture. So imagine this. A school. It's a spring morning. There's a smart system running, connected to multiple services, and it detects that the radon level is very high. So you have an automated system that checks, well, the wind comes in from the east and to the west. So, and by checking the weather report, and also you have a small sensor outside, you make the decision, so let's open these windows and get the air through, get the deadly gas out. At the same time, you get a report that in the park just east of this building, there is pollen this morning, which is not good because in the register we see that we have allergic children. So this is the kind of, and then the system obviously needs to make some smart decisions based out of that data. But these are the type of systems that we're going to see in the future when more companies open up their data, providing an API where you can grab the data and do something intelligent about it. Still, we have a couple of years until we get there, but there are some similar systems out there today. Let's talk a little bit about wireless protocols, whereas I would like to call it the battle of standards. I'd like to show you this one first. You know why this is funny? Because it's true. Yeah, because it is. And it doesn't only apply to wireless standards, it applies to all standards, cable standards, software standards. It applies to many things. For me, who comes from the embedded world and the connectivity world, it definitely exists, and it's a problem. So if you're going to design an IoT type of solution, you need to first decide of which embedded solution are you going to have, which supports which connectivity. You need to define which of these protocols you're actually going to use. What type of network are you going to pass this information on up to the cloud? Fortunately, to pass it up to the cloud, it's quite simple. It's like 3 or 4 or 5 standards that you can use to get the data up. So in that sense, it's quite simple. And typically, your company is also biased when it, or you typically, some companies, I say, are typically married to Microsoft, and they won't even touch the other vendors. And that's really good because then they don't have to make that decision. So companies typically have their, they have their partner, they have their cloud provider already, which is good. But there's a lot of problems going on here because it's just a complete mess. So the question is, if you're going to design an IoT product, how do you know which solutions are good, which solutions are bad? How do you know if somebody or something is good or bad? And can you take all these different solutions and just put them and compare them apples to apple and make a decision out of it? I don't think you can. I don't think that's the way you should do it. You should never just pull up all the different scenarios that you can, handle for your solution. What you need to do is you need to dig down to the problem statement, figure out what is the actual problem you're trying to solve. And once you know that, you look at the protocol, the solution, the framework that is available, easy to you, in order to solve that problem, instead of just looking at all the different solutions. So, back again on wireless technology. And the reason I'm actually, even though mentioning this at a software conference, is that most of these relate a lot to software. Most of these are actually software configurable, as I told you earlier. And it's important to know that for software developers, that hardware is becoming a commodity, and more things is actually fully software configurable. Anyhow, to make you understand a little bit better when it comes to wireless communication, there's 2 different things you can separate all the different wireless protocols into. Either it's the short-range networks. That's the kind of typical ones you have in the home or in an area or at a conference like this. It's like the Wi-Fi, Bluetooth. Z-Wave is popular for home automation people. Thread is something that's coming up more and more. It's Google behind that one. And you have the wide area networks. Now, the wide area networks is the one that typically they have a base station or they have some sort of network attached to buildings that covers a bigger area. This is where smart cities comes into play. You have the 5G that comes up, I think, to 2018, if we're lucky. It's going to be able to handle data rates up to, I think it's 10 gigabit per second or even 100. I saw an interesting movie from the US where they had a race car driver that got a VR headset, or it was an AR headset, a VR headset. And they attached a camera in front of the car, and then they blacked out all the windows. And then this camera sent information over 5G to a service that sent back to his headset. So he drove full speed on the racetrack, basically with a feed through 5G, which is quite crazy. And now, it was interesting to see. If we talk about smart cities, LoRa, NB-IoT, and Sigfox are like challengers right now. LoRa and Sigfox are already deployed. For example, Switzerland have 99% coverage with LoRa. NB-IoT is something that is upcoming. You see that Telia, Telenor, the local companies, they invest heavily in it. And there's also a lot of other companies throughout Europe that are actually investing in NB-IoT. And the cool thing is that this is a completely new part of the LTE standard, and it's enabled by making a software upgrade on the base stations. So LoRa Sigfox, you need new hardware to be placed out for the new network. But NB-IoT, you make a software upgrade to the base station. Not all base stations, but the newest ones. You make a software upgrade, and you have this new technology that you can utilize. You can connect your product up through the base stations, which enables a lot more cooler applications in terms of IoT. So let's talk about some Norwegian innovation examples. How many of you are from Norway? All of you, maybe almost. I already mentioned AirThings. So I'm going to talk a little bit more about that. How many of you know Disruptive Technologies? Raise a hand. A few. Okay, cool. This is going to be interesting. You're going to see some awesome shit over here. AirThings, let's start with them. I talked about them. They're visualizing air quality. So we have around 300 deaths per year in Norway due to this deadly gas. And it gets trapped in basement and things like that. So this company was originally a hardware company. They made this sensor. They had engineers doing the hardware, doing the production and things like that. They wanted to make this smarter product. They wanted to make a connected product. They wanted to make an IoT product out of this. So they added some software, but then they realized, okay, if we're going to make an IoT product out of this, we're going to need a couple of things in order to do this. We're going to need connectivity. We're going to need security, privacy, apps, web. We're going to have to do a complete cloud solution, complete architecture for that. We're going to need service design. And we're going to have to do system integration on this and connect it to business models. Now, if you take a look at this, the amount of new things they need to add internally in order to make this happen, I see a lot of software engineers. Connectivity, that's a software engineer. Security, privacy, that's a software engineer. Apps, web, cloud, service design, system integration, they're all software engineers. So all these companies who have products, who have hardware, if they want to make smart, connected products, they're going to need a lot of software engineers. So being a software engineer is a very good place to be when this IoT wave is, well, it's already ramping, so there's definitely going to be a big need of software engineers. So I like to talk about AirThings because they are in the change of, going into this type of market. So they were quite surprised on how many software engineers you actually really need in order to make a product, an IoT product. So, moving on. Wouldn't it be nice? Every time I read that, I always think about Beach Boys and their song. Anyhow, knowing that the operation looks after itself. And that's kind of the tagline by Disruptive Technologies. So what they've created is a small sensor. See if I have one on here, maybe, if I'm lucky. Maybe I lost it, it's so small. So a small sensor looks like this. And it's quite unique in the way that it actually hosts multiple processors. It has multiple sensors. It has a battery and a full radio circuitry in this small package. And what is that? Why is that interesting? Because there's a lot of different IoT devices that can do the same thing that this can actually do, which I'm going to tell you about soon. But the key here is it's extremely small. So with this sensor, you can actually fit it in door openings, in windows, things like that. And why would you want to do that? I'm going to talk about that in a minute. It's totally robust. So if you look at the package itself, they tested it in a chamber to simulate, I think, 5,000 meters of pressure. So it's really robust, medical grade plastic. In terms of lifetime, what would you guess this small sensor sending data, say 100 times a day? Let's say temperature data, 100 times a day. Give me, how many years would this last? Any guesses? 2? 5? 10? Actually, 15 years. So this can measure the temperature in here quite accurately for 15 years, sending the data up to the cloud through a small cloud connector. Not only that, it's in terms of range, we talk about 40 meters, 40, 50 meters indoor with this through walls. If you're outside, you can actually get up to 1,000 meters. And it's simple. So how is this actually, how do you deploy this product? Well, you stick it on the wall, you plug in a connector in the wall, that's it. It's running. No pairing, no sequence, no nothing. So this small sensor comes in 3 flavors. One is when you touch it, it sends the data. The other one is temperature, so it feeds you with the temperature measured. And the last one is proximity. And that's quite interesting, because if you place this in a door, it will actually tell you instantly when you open the door and when you close the door. Same with Windows. It's going to tell you instantly when you open it, when you close it. And you can actually ask the system if it's open or if it's closed. It sends this data to the cloud connector. The cloud connector simply operates as a base station. It doesn't know a specific sensor. It takes in all the sensors that are running their protocol and sends that up to the cloud. It doesn't even decrypt it. So the encryption is end-to-end, all the way up to the cloud. So there's no way to intercept the packet in the cloud connector itself. The cloud connector can support several thousand of different of these sensors. You can imagine in this conference, maybe you have 4 cloud connectors, and you cover the entire arena with a lot of sensors placed out. They're using Google's cloud solution, but that doesn't really matter, because as a developer or as a company, if you want to play around with these things, you just access their API. They have 2 APIs, one REST API and one gRPC. And this is the way that most of IoT companies are going to deliver their solution. They're going to deliver it in a way that is similar to sensing as a service. So that means that you would, for example, pay a small fee every month for a certain amount of sensors running your system, which you access through an API where you have credentials. And that's where many IoT companies are going to be in a couple of years. Instead of selling the product, you're going to pay for it in a monthly fee. So what Disruptive Technologies is doing, they're targeting different type of applications. For example, do you know that in almost all buildings you have fire extinguishers and you have actual people walking around checking that those are there all the time? What if you can just place out a sensor instead? Then you'll know if it's gone or if it's not gone. So these are the kind of different scenarios that they're trying to cover by this small sensor that lasts 15 years, which you more or less just place and forget. So we at Webstep, we thought it was cool, so we wanted to do a hackathon. Do you know what a hackathon is? Of course you know what a hackathon is. So we took a couple of sensors, we took 30 consultants, we had a day, we played around with it, and we come up with some pretty cool ideas. And I just want to share a 2-minute short video, what we actually managed to do during this hackathon. See if we can get it working. There we go. It's just 2 minutes. Yeah, so we were quite surprised actually how cool demos we were managed to do during these 2 days, and getting the sensors up and running. That's what kickstarts the whole. It's just you connect the things and it works in half an hour. You're up and running with actual development, and that's what I want to see with all those different IoT solutions that's going to come. It needs to be easy to use. Just mentioning a few things about hackathons that I think you should bring with you into your companies. If you're not doing hackathons, you should definitely do hackathons, because in a business sense, it actually allows you a way to look at new technology, which is something all companies need: innovation. And by doing hackathons and evaluating new technologies or methods or platform, it allows companies to assess new possibilities, and you take new approaches. For the individuals, obviously, you play, you have fun, you innovate, you actually build your competence, you motivate yourself, and allows you freedom to do whatever you want. Typically, you have some guidelines for a hackathon, but in the end, you end up with something completely different from what you wanted to do in the first place, which is really good. And this is important for all software engineers to get this opportunity. So if you don't have hackathons at your company, have hackathons. Now, I will just have a few more slides. I want to talk about the future, what we can try to think about when we look at the future. There's always people that says that hypes like IoT, blockchain, AI, all those things. There are always people who are disappointed that the technology isn't really there, because typically humans think in a linear way. Technology is not evolving linearly. Technology is actually evolving exponentially, and it's evolving so fast that the humans can't actually keep up with it. We can't keep up with the technology that is happening and all the new stuff that is happening all around the world. So if you think back 10 years ago, we got the first iPhone. Moore's law says that every 18 months, the amount of transistors for a certain space will be half. So it means that either you get twice the processing every 18 months, or you can do optimizations every 18 months. And if you look at iPhone, 10 years ago we had the first iPhone. Today we have a completely different type of iPhone. The advancements that's been made within those 10 years, that's what we can expect in 5 years. And after those 5 years, we can expect that change in 2.5 years. So that's the exponentiality that we're going to see with technology. Some people say that we are soon going to go into this hockey stick and it's going to take off. It's already happened. It's already taking off, and we're doing significant advancements. And throughout this conference, people said that, well, Moore's law, it isn't really valid anymore because we're going into quantum physics and so forth. Well, it's not true, because IBM did just announce a 5-nanometer technology just the other week. So we're still following Moore's law in a sense. We're still seeing advancements that's going to keep up with these exponential growth. Now, Charles Darwin, he said that it's not the strongest of the species that survives, nor is it the most intelligent that survives. It's the one that is most adaptable to change. Now, what does that say combined with the statement that technology is evolving faster than our ability to adapt? It's a bit contradictory, and it's a bit scary. So there is change coming, and we need to be able to actually follow the change that is coming. Now you may wonder, why is there a Lego Stormtrooper on my slide? And obviously I'm a Star Wars fan. I'm also a Turtles fan, if you haven't figured that one out yet. But the reason why I'm having this is because I can't help to make comparisons with IoT and Star Wars. If you think about, if you've seen, how many of you are Star Wars fans? Yeah, some of you, that's good enough. The first movie, Phantom Menace, which is, by the way, horrible, not the first movie that came out, but the first movie in the sequential order. Anyhow, they talked about something called midichlorians. Midichlorians is what enables the force. It's something that is in everything, in all things, in people, in whatever, that communicate to each other. Do you get any connections? It's the exact same thing as Internet of Things. It's things that people have, things that talk to each other. Not only that midichlorians, if you look at the robots, that's AI in itself. If you look at the clones in Star Wars, they were actually, they had an implant that Darth Sidious actually, in an instant, took control of all the clones and managed them to, well, do awful things, so that's not a good thing. What else is there with Star Wars? Well, it's the Death Star. Death Star is like the coolest smart home I've ever seen in my life, right? So there's a lot of things in Star Wars. Anywho, let's talk about the actual things I was going to talk about. So summarize the best practices that I've learned throughout being supporting customers worldwide with IoT development. First of all is battle of standards. First of all is if you're going to do an IoT project, don't sit down and compare all the different protocols, all the different things that you can read about on the web. Try to get your problem statement and the actual problem you're trying to solve, and then check availability for that. Don't compare, for example, Sigfox, LoRa, NB-IoT, unless there's actually connection in the country where you're going to release your product, for example. And you can do assessments by doing a hackathon. Try it out. Is it feasible? Next step, technology acceleration. The technology is moving really fast, so you don't have time to sit down and do 100% assessments of a technology or a method or something you need to do. You need to not overthink and just do stuff, try stuff, run pilots. You have to try it out, otherwise you can't keep up with the technology that is advancing. Thirdly, it's a bit contradictory as well, because keep it simple, stupid is really important when you're designing things. I have so many customer stories that I could share with products that they're adding features, things which are completely unnecessary and just causes problems, and it's a total mess when they release it. So keeping it simple, which is contradictory with my next step, you need to have security from the start. You need security by design. With IoT, you need to keep security as a concept all the way from the start. And that typically isn't the same as keeping it simple, stupid. But in a way, keep it simple, stupid, but also think about security. That's important. Last slide. Future. Today I've talked about Internet of Things. I talked about how we get in data from the real world, how we collect the data. Talk a little bit about how the data is going up to the cloud. So we have this big data. We have huge amount of data that needs to be able to be processed, handled. You can do predictions, so forth. Combining them with a topic I haven't actually said anything about during this talk, but blockchain, which is sort of a distributed ledger technology. It provides a way of recording transactions and digital sort of interactions in a way that is tamper-free, secure. It's quite transparent, and it's easy to audit. So this is the type of technology that we're going to see is ramping out in terms of communication and storing things that need to be tamper-proof. Combine that with machine learning, with specifically maybe deep learning, which is the most popular algorithm that you run in those type of systems. If you combine all this, you're going to have something quite amazing. We're probably going to reach what is called the technology singularity, which means that robots actually exceeds humans in intelligence. But it's going to happen. But we don't really know if it's really, really good or if it's a disaster. The only thing we know is we're going to reach that point sooner or later. Some people, they state that it's going to happen in 2035. I really hope I experience it myself. And I've heard multiple people at this conference talking about just that, so that ought to be interesting. Most of these things like 99.9% of all the things that needs to be done here is software. So the future is software. This is where software engineers are needed. And not only this, there's also multiple other fields that ties into this beautiful danger that we're going to have in the future. By that, I'm not going to talk so much more because it's late in the day and it's the last day. And I know all of you probably want to be somewhere else soon. So I'd like to allow you to ask me questions if you have any. Rock solid. I'll be staying here for a while if you have some questions. Cool. Thanks.